Hello, it's Keith here and welcome to Lesson 52 of the platform-specific series of my Z80 programming tutorials. Now we're going to be looking at the MSX1 this week. We're going to be learning how to use the 768 tile mode to split the screen into three and use three different tile maps for the screen, and this will allow us to show an image covering the entire screen. But if this is not your first video watching, you'll notice that things are rather different today. I'm running a webcam, I've got a mouse highlighting cursor set up, and I've also got a on-screen keyboard. So if I press the control key here, you can now see what keys I'm pressing. So let me know what you think of this. Is this a style you like? Essentially it's copied off from my live streaming channel. I've learned OBS a bit better and I'm feeling a bit more confident with the hardware, and I want to try new things to make the content more engaging and more enjoyable. So that's what we're going to be doing today. We're going to be looking at the MSX1. We're going to learn how to get the Chibi Akuma's logo onto the screen in full color. This has essentially been upscaled from the Spectrum version. It's been slightly improved, could do far better, but I'm doing a fairly limited job it's only an example really, so it's not going to be amazing graphics, but that's all we're going to be trying to do. So okay, well let's have a look at the AkuSprite Editor and we'll see the actual graphic that we're going to be working with. So here's AkuSprite Editor. This is an updated version and you can see we've got a new image here. So this has effectively been converted from the Spectrum version and I've just made a few slight tweaks. We've got this new MSX8x1 option here, and this will convert from a 16 color image down to the MSX1 limitations. What does that mean? Well, the MSX1 can only have two colors on a line. One's the foreground color and one's the background color. And by a line, I mean an 8 pixel wide, 1 pixel tall image. So you can see this has got two colors. This has got red and blue, for example, and this has got red and white. But if I try and put a single green pixel in, let's say here, I've just put this green pixel in here, well now there's three colors on that line and that's not going to work. So if I go here, enable MSX1 color mode, you see now the white pixel has turned green as well because it's physically impossible to have the three colors and the software is converting in the best way possible. AkuSprite Editor can also export this file if we go to the Z80 menu and select MSX file, and then the save MSX1 bitmap option that we were using before has now been enhanced, and it's now going to output two files, one that's the black and white information and one that's the color information. So there we go. So we're going to be looking at the MSX1 today. We're going to learn how we can do things. Now, as I say, the color information is essentially split into two parts. Each tile has 8 bytes that represent the 8 lines of that tile, 8 by 8 pixels. So one byte will contain 8 pixels worth of black and white information in the first area of the tiles. And you can see this is the effective black and white information of the image we're going to be viewing today. The second set of bytes is the color information. Again, there's as much color information as black and white information, which is very different to the Spectrum. And the 8 bytes will contain one color for each line. There's it uses a single nibble for the background color and a single nibble for the foreground color, and they define what the 1 and the 0 in the bitmap part of the tile actually mean. Now you can see I've kind of converted it here. I've basically set a couple of bits of the bitmap all to 1 here and most of them to 0. So you can see how the color information here will later be applied to the black and white information here, and that will build up the actual final image just here. So that's what we do when we want to create the image. Now, the problem with the MSX is the mode we looked at before was only capable of 256 tiles. The reason for this is that the tile map is using just a single byte per tile definition, so 0 to 255, so 256 tiles. But the MSX1 has quite a clever trick. What you can do is split the screen into 3 parts, and those 3 parts will use different tile maps within the memory. And so even though we're using a single byte to define the tile number will point to 3 separate sections of memory which will use different bitmap data and different color data. So that's how we are able to get our full color Chibi Akuma's logo onto the screen, and we've got far better color than the Spectrum could possibly imagine. Okay, so that's the theory, and you can see here what I've done is I've got the code. We'll look at it in a moment. The code, if we just use a single tile map, which is what we looked at before, you would see the same third repeat over and over again. But when we enable this special mode, which is really easy to do, we get the full color image here. So this is what it's going to end up looking like. Okay, well, let's have a look at the code and let's actually try it out then. So here we go. So this is the example we're going to be using today. I'm going to be using it with my standard tutorials, although if you enable this cartridge and disable this header here and the footer here, you can compile it yourself much more easily. I'm trying to make things more easy now for people who aren't using my tutorials, because I know they're getting quite complex with the multi-platform code. And a lot of it is that when I was starting out with things, it was taking me a lot of time to get stuff done. So I was trying to sort of merge everything together into one stream to make things easy to code and maintain. But now the tutorials are much more mature. I'm starting to branch out and make standalone tutorials that are easier for people to follow, but they're maybe going to take me a little more time to maintain. But as I say, it's all about trying to make things work for everyone and give people various options. So this one can be run in pretty much either mode, but I'm going to be running it as a general tutorial series, because if you're just downloading my stuff and want to compile it, this will work the easiest for you. Okay, so let's just run it now and we'll see it in action. So there we go. So there's the image on screen, exactly what you just saw in the screenshot, but I just wanted to show you it really worked. And let's have a look at how things are working. So when we do an export of a color image in AkuSprite Editor, it will save a pair of files, MSX1 screen, which is basically the black and white data, which is the same as we've looked at in previous lessons. But now there is a second file being exported by this new version, MSX1 screen.raw.col, and this is the color information for that raw file we exported here. So we're loading these into two memory addresses, and then we are copying this data to the correct locations. Now, before we look at that, the first thing we have to understand is that we do have to define the screen in a slightly different way. Here's our classic settings we were using before, and most of them are the same. But you'll notice here that registers 3 and 4, these ones here, are quite different. They've been changed here. And this is what is giving that effect of splitting the screen into 3 parts and using a separate set of pattern data for each part, and that's how we get our screen to look so good. Okay, so all we need to do is use this information here. If you enable this one, you will get that dodgy example I showed you earlier. You would get this here. That's how I created that. So we're not going to do that because we want to see how to do it properly, of course. So we're going to look at that. So just like in our simple series, we're sending all the screen definition information with these commands here, just transferring them one by one to the hardware. And then what we're doing is we're setting the write address of the memory, because we want to set the black and white information here, and that goes to memory address 0 in the video memory. We're then defining the source as our test sprite, the size is test sprite end minus test sprite. This is the black and white data, and then we're using this little command called outDE, and all this does is it repeatedly outs until DE equals 0 to the port C, and the port C was actually set by set write address here. I'll just show you that. There it is. So it's setting that just here. Now, after we've done that, we are setting our color information here, and we're just transferring that here. And then we're using the outDE again, and this goes to memory address 2000 here. So that's the second part that has to match this here. Now, I'm setting all 3 banks of tiles simultaneously because they are consecutive in memory, so that's why you're not seeing 3 separate batches of writes to the 3 separate memory areas. Once we've done that, all we need to do is set all of the tiles of the tile map to point to the correct tiles within this image. The image starts, of course, at 0, goes all the way through to 255, and then loops back because it does it 3 times for the 768 tiles that make up the screen. Now, in this case, I'm just using a loop here, but alternatively, you can use the fill area with tiles function that I did before. You've got this version here. If we just run that. You can see that works just fine as well. So you've got sort of various options. Again, I wanted to try and make things as simple as possible, so I'm not using the fill area with tiles command this time, but it does work just fine. As I say, we've got these 2 sets of data here, the black and white data and the color data here, and I can just prove that to you if I just rem out my color data here and I put in some random test data here. Let's say we put in E3. Let's try that. That'll probably get us some quite interesting colors there. And now we've got that horrible colour scheme there. So, of course, if we swap these 2 over, we'll probably get something a little bit nicer here. Actually, not much better at all. Okay, well, you can see, though, that the nibbles will define the foreground and the background colour. So I'm forcing all of them with this DS statement here, which is just defining a sequence of 768 tiles worth of 8 bytes here and setting them all to 3, but obviously we don't want to do that. And as I said before, if we define a few bits to 1 here, we can see the actual color information just with some sort of test data to see what's actually going on. And you can see that's how I created that image there. So honestly, it's very, very straightforward doing this. It's really just these two lines that actually enable the screen to use this new mode of 768 tiles, and then it's the actual work of AkuSprite Editor that's doing the export job, and that's what we have to do to get the screen to look right. Anyway, this explains how we can use this mode. Now, the difficult thing is that, of course, this is just fine for an image where we're showing an entire full screen graphic like this. But if you are looking to use this in your game, you're probably thinking, well, now I can have 768 tiles on the screen. Technically, that's true, but it's going to put some serious limitations on your game, because if you're scrolling horizontally, then the sky part might be using different tiles to the land part, and there might be an underground part or something at the bottom of the screen. That's going to work fine for a horizontally scrolling game. But how are you going to make a game scroll vertically? The other problem is how are you going to draw your text? If you've got a game with like text pop-ups that appear in different places on the screen, well, your font's going to be some of those tiles. So you might see in some MSX games the top 2/3 of the game are the game map, and you'll have your sort of characters, like your Mario characters and your background. But then the bottom part will be entirely made up of the GUI. You'll have your score, you'll have any items the character's holding, your remaining lives, that kind of thing. And that will be because they've split it up to make the first two parts use one set of tiles, and then the third part use the font tiles and any other bitmap graphic tiles for the GUI. So that will be the kind of thing they're doing, because if you need that font in all three areas, you're going to have to define that font in all three areas, and that's going to start using up a lot of your tiles. My 96 tile font would use up 288 tiles, leaving only 480 left. And even that's assuming that there isn't repetition between the three areas of the screen. So splitting the screen into three is going to be great for an example like just showing this massive graphic here. But for gameplay, it's going to get a bit more difficult, and it's going to really depend on what kind of game you're creating. Anyway, I hope you found this interesting. We've covered another quite curious mode of the MSX, and AkuSprite Editor's got a bit more powerful as a result, so I'm quite happy with that. Please let me know what you think of the new ideas I've done today. Do you like the video? Do you think the mouse highlighting is going to help? And what do you think of the on-screen showing of the keys? Does that help you at all, or is it distracting? Let me know, and I'll change the way I'm doing things accordingly. Anyway, I hope you've enjoyed this. Thanks for watching, and goodbye.